which is Derek Troy West. He's going to talk to us about data-orientated delivery. I won't spoil any of the stuff that he's going to share, but there's some products and stuff that he's helped develop and stuff which I think he's going to share with us and talk about this evening. And after Derek's talk, we're going to do the community marketplace. So that's an opportunity if people are looking for work or people are employers and looking for people to come and work for them. Then you can have I think it's a 60-second pitch at the end in Community Marketplace. So if you think about anything you might want to present or share with the group, whether it's opportunities for work or present yourself as available and looking for work opportunities, feel free to hang around after Derek's talk and share with the group a bit about what you've got to offer. So yeah, there's some rules for the community marketplace. 60 seconds, so be prepared. So we're giving you forewarning now. You don't really actually have to stand because this is over Zoom. You're welcome to sit as well. We can share any details and links and stuff if you've got perhaps a product or something that you've developed as well that might be relevant to the data engineering community, and we're happy to share that sort of information. So before we get too carried away with the marketplace, I'll hand over to Derek and look forward to hearing about data-orientated delivery.
Thank you, Tim and Hamid, and thank you for having me with you today to talk about data-oriented delivery and a little bit about our product Operator. And also, I see congratulations are in order for passing 3,000 members in the Meetup. That's really exciting. That's must be one of the biggest meetups in Melbourne today, I think, for technical stuff. So congratulations, that's really cool.
Yeah, thank you to speakers like you, I would say.
Well, hopefully this evening goes okay. So I'll tell you what I'll do to start off with. I'll just share my screen. And I will just ask and check whether everybody can see my slides at the moment. Can everybody see those okay?
Yep, I can see them.
Great. So yeah, this talk's called "Kill Your Darlings," which sounds like a little aggressive actually, but it's an old literary term that means to give up on some of the fancy things that are possibly extraneous, things that don't really need to be there. And really it comes from the last 8 years of my working career after I moved to Melbourne. And it comes from a shift in the way I work and the teams that I work with, from a very object-oriented worldview, which is a very common way of building applications for the enterprise, to more a data-oriented approach of delivery. So I just want to share a little bit about me. My name is Derek, of course, and I'm the founder of a company called OPERATR.io, and I'll give you a little bit of a demo of that in a moment. And I run the Melbourne distributed meetup, so we get together fairly irregularly to talk about distributed systems that we might be using, our peers and colleagues. We've had some great talks in the past, so if you're interested in talking at that or coming along, look it up. And I'm predominantly a programmer, so my career has been fairly straightforward. I've worked in New Zealand, the UK, and Australia, mostly building enterprise Java applications, we used to call them. So all the way from 99, I was working in telecoms in New Zealand, working with Java. And then I moved to the UK and I worked with Java in finance all the way until 2012, when I found myself in Australia. And when I moved to Australia, I decided to try and branch out and do something a little bit different. I started working with distributed systems a lot more than the sort of fairly enterprise-y type systems I've been working with in the past. And I switched my language of choice from Java to Clojure, which I want to share a little bit of that with you today and show you some of the advantages of using Clojure for data-oriented delivery. And really, that change in the way that I approach solving problems from Java to Clojure and from enterprise to distributed systems, it really reflects a change, I think, in the market that we've seen through that time as well. That I think when I was working back at banks and life insurance companies in the early 2000s, the things that we were really concerned with were understanding the business requirements, the risk of delivery, because actually in the early 2000s, I hate to sound really old, but oftentimes there was concern that projects could even get delivered online because delivering stuff online was really quite new. And then security was the thing that everybody was always concerned about, and we are still quite concerned about today. But more since I've lived in Melbourne, I feel that those concerns for the enterprise are changing. And today, I think many of us, we feel a real pressure to deliver systems that really work in real time, they scale, and they're highly available. That's what today's talk's a little bit about, how we do that with data-oriented delivery, the move from using traditional database style approaches to delivering with a distributed system like Apache Kafka, changing from a traditional Java and JavaScript delivery programming model to a data-oriented model with a programming language like Clojure. And the way I'm going to run through today's talk is we're going to, I'm going to show you, it's a bit of a show and tell. So I'm going to show you the thing that we've built with just data functions and Apache Kafka. We're going to talk a bit about Kafka and databases, Clojure and Java. And then at the end, I'll do a little bit of live programming for you, which hopefully will be entertaining in a technological way and not in a car crash kind of way, but let's just see, let's see how that goes. Live programming is always entertaining. So I want to reduce the scope of what I'm going to talk about first off, because when we're sitting down programming, there's all sorts of different things that we could be building. In my career, predominantly, I have built products for businesses. So the tools and techniques that we use for those particular types of delivery might be completely different from what you would use for if you were delivering frameworks or libraries or languages themselves. But most of our commercial work is about actually achieving delivery for a client, right? Getting a product delivered, ticked off and paid for. And what do we really care about when we're working, or what do I really care about now? First thing, I care about delivery because that gets me paid and gets my family fed. The second thing I care about is quality because that gets me paid again. And that's also extremely important. And because I'm long in the tooth now, I'm quite old, I find myself, I'm really concerned with, am I enjoying my day-to-day work when I'm working as a programmer? And what I've found as I've shifted from an object-oriented mindset to a data-oriented mindset and an enterprise mindset to a distributed mindset, my tools have changed. And I'm having extraordinary fun with the tools that I use today. And my team that work with me on OPERATR, I think we have a really good time delivering every day. And that's important because I'd probably just give up on programming, I think, if I wasn't working with Kafka and Clojure today. Clojure in particular has been a real breath of fresh air for me after a long time working with Java. So I've got some simple principles that I try and keep in mind when I'm working towards delivery. And that is to favor simple tools where you can, when they're available to you. Use as few of those tools as possible, and to know the trade-offs between those tools. And that's really the craftship in what we do, is understanding the trade-offs and the different tools available to us and when it's right to use the tool for the task. So what we build in Melbourne is a system called OPERATR. And if you're familiar with Apache Kafka, you might be interested in OPERATR if you use it. It's a toolkit for Apache Kafka. It's the missing piece of the puzzle that I've had over the last 8 years when I work with Kafka, when I'm building systems. For engineers that are working with Kafka, you need a control panel. You need some X-ray goggles. You need a way of getting in and looking at data on topics and understanding how your cluster's working. and really drilling down into not only how the cluster's working and how your database is working, but how your applications that sit on top of Kafka are working as well. And this is the gap that OPERATR fills. It's just one Docker container, and it's like you don't have superheroes without a cape. It's like a cape for developers that are working with Apache Kafka. It gives you all the insight you need into how that database is working, how your applications are working. But the way it's built is kind of interesting, I think, because it reflects the way we think you should build applications that work with Apache Kafka, in that it uses only the simplest tools possible and as few as possible. So OPERATR itself, this console for Kafka, it is a single Docker container that is on Docker Hub. You can pull that and it connects to your Kafka cluster just like any other consumer or producer that connects to your database would do. And it has no other moving parts. It actually only uses Kafka streams itself internally to do all of its computation that it needs to do, and Clojure. So it's a really simple little package. Get it up and running in a couple of minutes. And when you start an operator, it starts reading metadata from your Kafka cluster periodically, every minute. And the first thing it does is it writes that data straight back to Apache Kafka, and then it performs a streaming compute using Kafka streams over that data that's in your Kafka cluster, and it enriches that data and produces sort of derivative information for you, metrics over a time series. We smash all sorts of metadata together to give you interesting insights like which consumer host has the most lag and things like that. But I think the interesting thing about how OPERATR is put together is that there isn't a traditional database. There isn't in any way a traditional computation system. It's Clojure doing streaming compute over a Kafka cluster that is also the Kafka cluster that it is observing. That gives us a whole bunch of advantages in terms of how we can deploy and provision OPERATR. It also means there's no data leaves your network, and it's just a very simple little clip-on to Kafka in a way, which is quite nice. So I'm going to give you a little demonstration of what a system looks like, what a system can look like when it's built only with Kafka and data and functions. So this is what OPERATR looks like. When you first land on it, it's got an overview page. It's got a nice little set of dashboards here that tell you things about your brokers and your topics and your groups and how your data is distributed through your cluster. And I guess at this point, it almost might look like a graphite dashboard or something. It's showing you metrics, except OPERATR gives you a lot more than that. It gives you the ability to take a look at data on topics. You can really drill down into what's happening in your cluster in terms of messages that are being produced, and just move my Zoom. Messages that are being produced onto topics. You can search for messages by key and really drill down into how your cluster is, the sort of the life cycle of data in your cluster. You can produce messages back to topics. There's all sorts of stuff that engineers that are working with Kafka really need to be able to do every day. And this is, we talk about Kafka blindness because the number of times we build projects with Kafka and then just not really being able to get to grips with how it's working and how our systems are working. We're trying to solve that problem. So again, we've got an overview of all the brokers. It's quite an in-depth little system where you can filter on different, there's no data in the audit log. You can filter on different topics and by different dimensions. So actually even the user interface itself is very data oriented in that it's got a sort of a faceted view of everything that's happening in Apache Kafka at the time. You can look at all the configuration, you can create topics. You can, if anyone's using schemas in the schema registry, you can drill down into schemas and take a look at the different versions of schemas that have been used in your system so far and diff them and stuff like that. So it's really a Swiss Army knife for Apache Kafka for developers in this space. And that's probably enough of a demo. I just wanted to, I think oftentimes I come across teams when I'm working on the consultancy part of my business who are approaching Apache Kafka, or they're evaluating it, and it's sometimes hard to understand what sort of systems you can build with Apache Kafka and only Apache Kafka in a real-time stream and compute sort of way. And OPERATR and the user interface of OPERATR is a really good example of something that you might look at that and think, well, I've got a task at my job to build something for some business people that looks sort of similar in a way. It's a web app that's doing some real-time stuff, and it's got some dashboards, and I've got to be able to affect some changes. You can do all of that with Apache Kafka if you're interested in. And there are reasons that we do that with Kafka, and it really all does come down to real-time scale and availability. If you have to do those things, if they're on your list, those non-functionals to support them, building a system with Apache Kafka where you might have a Java process rather than Clojure that's in a Docker container that's running against Kafka clusters, doing all sorts of streaming compute, as opposed to, we could build the same system as OPERATR, but we could have that writing to a traditional SQL database. It could be pulling metrics or putting it into some other sort of time series database. And why don't we do that? Well, the things that we're concerned with today are really all about real-time scale and availability. And those things require distribution. And it's the distribution that Apache Kafka gives us that facilitate. More in OPERATR's sense, we're really concerned about scale and availability. And I'd like to sort of explain to you what that means for OPERATR and briefly how Kafka supports that. Because I understand not everybody has got a lot of experience with Kafka at the moment. We don't have the several hours it would take to dive into exactly how Kafka facilitates all of these things. But I think as a starter for 10, everybody is probably familiar in one way or another that Kafka is a message broker. That's what Kafka started at as when it was first open sourced, I think 9 years ago. It's a really resilient, highly available distributed log, basically, that has a very, very simple semantics that you put messages onto it, and they're distributed and replicated. And as a sort of a store of data, Kafka has these concepts of topics that look a little bit like queues. And it's just a way of storing logs, basically, in a way that is highly available and linearly scalable. So if you have more logs, you can just have more Kafka clusters. And if one of the brokers in your Kafka cluster goes down, then your overall database should keep on working. That's the sort of way that traditionally people look at using Kafka if they're plugging it in to be a bit of part of an enterprise service bus or some sort of backbone for ferrying data around an organization. And OPERATR uses that. OPERATR reads your metrics and writes that data straight back to Kafka. So your own cluster stores the telemetry of the of itself that's served up in the dashboard. But I think what's more interesting in that is not the distributed data layer that Kafka gives us, but it's the distributed computation that Kafka gives us in Kafka streams that is really super powerful. So not only can we, if you're building a system that is using a distributed message store like Kafka and relying on those abilities for scale and availability, then really you should be thinking about building your computation in a way that is also scalable and highly available. And preferably, if you're buying into the Kafka way of doing things, it should be scalable and available with the same sort of considerances and semantics that the underlying message broker itself has. And Kafka Streams is basically a programmatic model for building systems that scale and are available and operate in real time on the JVM today. And then the last little bit of Kafka, which is possibly a little bit less bulletproof and a little bit less ready for production, but we do still use it quite a lot in OPERATR, is Kafka as a distributed database where you can transform your topics and your streams more into materialized views that are indexed by key or by time range, and then you can query into that to produce results in a way that look a little bit more like a database. And then of course, Kafka's got a bunch of tools like KSQL and Kafka Connect that are either open source or nearly open source that are provided that really top off the pyramid and give an overall streaming compute platform that has the same semantics about scale and availability all the way up the stack. And that's what OPERATR utilizes rather than using a database in the back end, like a traditional Postgres or something like that. And that's because we really are concerned about scale and availability for OPERATR. So a traditional setup for OPERATR would be running against one Kafka cluster and monitoring that cluster, providing you all of the insights and control and access to it. You saw me running through in a demo quickly. But OPERATR can also manage multiple clusters at the same time. So you imagine you've got one operator running in a Docker container with a couple of gig memory and one vCPU. All of a sudden it's managing 3 Kafka clusters and not one. Well, that's actually probably okay. Those sorts of resources are going to work just fine for 3 Kafka clusters. But some Kafka clusters are bigger than other Kafka clusters, and there's more work that OPERATR has to do in that case to manage and read the metrics and compute over all of the snapshots and produce all of everything that needs to be done to keep that user interface useful for you as an engineering tool. So one option would be just to make a bigger operator, just to have 4 gig memory or 8 gig memory or 32 gig memory. But this is a game that it reaches a natural conclusion because one operator in our next, probably in release 43, we're on 41 at the moment, will be able to manage up to a dozen Kafka clusters. And at that point, we're not entirely sure what the sort of resource requirements would be for a single operator running that. And you know, who says you necessarily want to stop at a dozen Kafka clusters? You might want to manage many more than that. So OPERATR itself is linearly scalable. So one operator installation, rather than running one, you can spin up 3. And you might think to yourself, well, if I had a Postgres database, I could spin up 3 operators with 3 Postgres databases. But if you're not using the Kafka Streams library for doing your streaming compute in a distributed manner, then you'll probably have triple the work and triple the amount of data in your 3 Postgres databases. The smarts with Kafka Streams that it gives us is that each operator work shares, splits up the amount of computation that it has to do to cover the cluster set that you are monitoring, performs only the work that it needs to do, and then actually provides a unified user interface as well. So this is where using Kafka Streams as a programmatic model really starts to show real benefits to us, because OPERATR itself is a linearly scalable system. So you can just spin up 3 Docker containers with the same configuration. If anyone's actually using OPERATR today, I think some of our customers are on the video call. Don't go and spin up 3 operators tomorrow, because there's some configuration you need to apply that we haven't published yet. So please don't rush into doing that just yet, although we are talking with some people and trialing the multi-cluster stuff at the moment. So that's one facet of being able to run multiple operators, is that you can scale to compute over a bigger problem which is really applicable to lots of enterprise engineering today. It's something that we're often trying to do either in a traditional programming sense, or we're using AWS tool sets to, chuck things in S3 buckets and smash them with big hammers. The other thing, that ability to split the problem into thirds or sixths or so on, it gives us a solution for a highly available system. So Kafka brokers, a Kafka cluster isn't just one machine, it's often a minimum of 3 and often many more than that. And a common pattern for deploying a Kafka cluster is to split the brokers between availability zones, because the way that Kafka works is you will then be able to lose an entire AZ, and your Kafka broker, at least, your Kafka cluster at least, should still keep functioning. There is some operational stuff that happens in the background, but it's a very resilient distributed system that aims for availability. And because OPERATR is built with that Kafka really at its heart, OPERATR shares the same availability characteristics as your Kafka cluster does. So if you're running against a production environment where you've got your brokers set up, configured correctly to be across the AZs, you could choose to run multiple operators against the same Kafka cluster. And if you lose an AZ, your operators, you should still have access to that engineering console, as well as your cluster should still keep running. So that's some of the advantages that we get, scale and availability, out of not using a traditional database, but instead favoring to use Kafka as the delivery mechanism for OPERATR as a whole. And so just to recap, that real-time scale and availability, the scale and availability in particular, they require distribution, and Kafka provides the data storage and programmatic model to achieve that distribution for OPERATR itself. And I think for darling number 1, object-oriented design, the truth about Kafka and distributed systems is that they don't care about your domain model. The things that are important to you traditionally as a developer, building object hierarchies, are totally unimportant to how these distributed systems work, where they primarily they care about data locality, data temporality, how you've partitioned your data. But as soon as you start creating object relational graphs, you'll either have to shard everything, or you'll have to break those object relational graphs into a more of a data-oriented way to write your data out into the cluster, so that you can get some use out of that data in a highly available and scalable way. So that's one of the trade-offs with working with Kafka over a traditional databases. You really do need to have an idea of your read paths before you build your system, because without the ad hoc querying power of a traditional database, you can end up in a very tough place if you haven't considered the sorts of uses that you want for your data before you go writing them out into the distributed system. And there are techniques that we can use to prevent future selves from having too much pain, but it's definitely a trade-off over a traditional database system, that your ability to query data is definitely limited. So we take enormous value out of Kafka, not only in, our entire product is oriented towards value adding on Kafka and for engineers in that space, but we use every single part of Kafka to build our product as well and get the benefits of that scale and availability out of that. So darling number 2, and this is a real sweet spot for me, because I actually have a very limited career in programming, I guess. I've really only worked professionally with Java and Clojure, but I happen to have worked with both of them for a fair amount of time. And I like Java. I think I quite like the JVM. The JVM is the 800 kg gorilla in the room that is first class environment for delivering production systems. The advantage of using a programming language like Clojure is that it's much, much simpler. So this is a quote from Brian Gertz, who wrote Java Concurrency in Practice, and he's a big Clojure fan. And he remarks that Clojure is one of the few production quality serious JVM languages that isn't just let's do Java better. And that really resonates with me, because I'm going to do some live programming in about 2 slides, because there's no point trying to describe Clojure to you too much. I might as well just show you, because actually there's a lot of familiarity in Clojure for JVM practitioners. But this is the difference between Clojure and Scala and Kotlin, where Scala and Kotlin might be considered a better Java. And I'm sure I've heard great things about Kotlin, actually. I know quite a few people using it today. Clojure is radically different. So it runs on the JVM, and actually the power of Clojure really is that it's a hosted language and it runs in the browser as well, as we're going to see. So our product OPERATR is a Clojure. Well, actually, I've got a slide for that, so I'll wait for a second. But yeah. So Clojure runs on the JVM. It also runs in the browser. It's a Lisp, which don't let that put you off too much. It's a very old-fashioned way of programming. There's a lot of parentheses, but you get used to the slightly strange notation fairly quickly. And really, it's just functions and data. And that's what I mean by it's simple. If you're working in a data-oriented way with Kafka, and you're trying not to think too much about object modeling, which can be a hard thing if that's what you've been trained to do your entire career, using something like Clojure on the JVM, which interops perfectly with Kafka and all of the Kafka client libraries, but really only has functions and data, is a great way of not worrying about object modeling, because all of a sudden you've just got maps, sets, lists, and functions that operate on them, and great Java interop. So it kind of pushes you to build simpler systems that stick true to just data. And it's really deeply flexible language. So our front end, when you saw the demo before, that uses Clojurescript, which is compiled down to JavaScript. I played quite a large role in building that front end with my team, and I don't know JavaScript. So I guess that's a positive. I could build a user interface like that with my team and really have no interest in how JavaScript works whatsoever. It's used in the back end. So all of our streaming compute, all of the systems that run within the Docker container themselves, they're all running on in Clojure, packaged up as a jar file that runs just like any other jar file would with Java 11 if it's delivered in our Docker container. Our static site, actually, OPERATR.io, is built using Clojure, because Clojure data structures easily converted into HTML, and it's a real convenience for us. And we use the same semantic UI CSS framework on our static site as we do in the front end. So when I was talking about using as few tools as possible, it's not just the product that's delivered using Clojure, it's actually the entire company that is serviced with Clojure, because our admin services, if you sign up for a free trial license of OPERATR, that'll be some Clojure running on Clojurescript running on Node in AWS Lambda that executes that little request and generates a cryptographic certificate for you and sends it, emails it back to you, integrates with Amazon SES and all of that sort of good stuff. And that's what I mean in my slide about using the simplest tools possible and as few tools as possible. We don't just have one programming language for solving all of the problems across our small enterprise. We have one way of thinking, which is very, very data oriented. So literally everything that powers our company is built around maps of data, lists of data, often lists of maps, sets, functions, and Java interop, basically, and interop with the browser as well, interop with JavaScript libraries and stuff like that. So because I've talked a bit about Clojure and it probably sounds completely bonkers, I wanted to show you a little bit about the power of data-oriented programming with Clojure in the browser and on the JVM. So I've already showed you a demo of our application. So this is actually a ClojureScript using a library called Reframe that sits on top of React, the JavaScript library, to present all of the information to us in our live system. So this is actually running within IntelliJ at the moment, which is my development environment, which is probably very familiar development environment to Java developers out there. I've got a little window over here with that I can touch some Clojure into, and it gives me a response that evaluates an expression. But it also happens to be running our developer build of OPERATR that is also running against a Dockerized 3-node Kafka cluster that's running on my machine just for demo purposes. That's what that looks like. This is my setup when I come and work on OPERATR in the day and add new features to it and stuff like that. Probably the most powerful thing I've lost my, there we are, there's IntelliJ. One of the most powerful facilities using Clojure is to be able to generate data. So we have a namespace called OPERATR generate. And when we're trying to build out new functionality for OPERATR, we'll often start with some synthetic data that we expect would be similar to the shape that we would get from Kafka if we went to Kafka and tried to get some information from a running cluster. So this is, in a very Clojure-ish way, me generating some synthetic data in a REPL that if my operator went to a Kafka cluster and said, tell me about yourself in the simplest way possible, it's going to get a map of data back that looks very much like that. And actually, because I have an operator running in my REPL, I can get the admin client from the state that's running in my REPL. And you can see here, actually, this is just a Java object, right? It's a Kafka admin client, which is a part of the Kafka framework for connecting to Kafka clusters and figuring things out about it. We've got in Clojure, functions are broken into things called namespaces, which are packaged a little bit like Java classes are. I've got an admin namespace called OPERATR Kafka admin, and I can require that in my REPL here, which is the way I is the way I pull things in to work with functions and data in Clojure. And this namespace has, I should have thought about this beforehand. It's got a little method called describe cluster. So I can do, I can find the Kafka admin client, and I can say admin describe cluster with that admin client. And you can see, actually, I get some information back that looks a little bit like my generated cluster snapshot. It's not quite the same because this is the raw data that comes back from Kafka. It actually comes back from the Kafka admin client as a big object graph, like a traditional Java object-oriented way of doing things. And we immediately convert it using this function here, pdatify. There's a Clojure way of doing things. We immediately convert it into a Clojure map. So you could imagine this cluster and brokers and controller would all be objects with getters and setters and stuff on it. We're not interested in that at all because we're really, in the operator sense, we're really only interested in gathering all of the metadata from your cluster as quickly as possible, munging it together and value adding on top of it. And whatever domain model anyone's anticipated was the right one for Kafka admin stuff is definitely not the right one for what we're trying to do. So we discard all of that immediately, get straight to the data. But the advantage of being able to generate data like that is that we can run completely generative systems. So we have a tool that we call live development. Within my project, I can start something that looks quite a lot like OPERATR running against a live cluster, and it'll just take about 10 seconds or so. But it's not actually a live system at all. It is entirely running within the browser. It's using that generate namespace to generate a stereotypical data set for a Kafka cluster and to make it available to the user interface without actually talking to Kafka at all, which is really useful for demo purposes. It's useful for development. You know, our user interface is probably about a half of our code in our system, and this is how we test ideas and change things around without having the rigmarole of running Kafka clusters and doing deployments and CI/CD to see how things work, because we're data oriented. We have a understanding of what the data set is that comes out of a Kafka cluster, and we just generate that data set, plug it into the front end, run it entirely in the browser. And as far as the front end knows, it has absolutely no idea that we're working with generated data. We can do all of the stuff that I was doing before. I can look for data on topics, and all of the results are just generated, and all of it's running within the browser. And this is actually also really useful for demo purposes. So demo.operator.io is exactly this. We deploy it, we push it live, we tell people to have a look, because we want people to have the easiest way of playing with the product with the lowest level of commitment possible. So, you know, just having something that is the latest live version of the product running on generated data is a really powerful way of working. And I guess my other favorite thing about Clojure is that, as I said before, one thing I'll demonstrate with Generate, and I've only got a couple of minutes to run, so don't worry, I'm not going to keep you bored out of your skulls. I think by rambling on, one thing that's really useful with the generative data stuff is we can change the stereotype of the cluster just by, we've got some data that we declare here. It says I've got 6 brokers. Well, I'll change that to 3, and I might just have 3 groups, and I might just have 5 topics, and I'll reduce the number of partitions per topic, and so on and so forth. And I can change that and then reload my page here. And you should see, hopefully, my machine's running a little bit slowly because it's trying to do too many things, I think. Oh, what has that done? That's great. Who knows? I've broken something. Oh, it might have been recompiling. Yeah. So now you can see I've got 3 brokers where I had 6 before, and I've got 5 topics, and my graphs look a little bit less frenetic. And I could do the same the other way. I can say, what happens if I've got a 50 node cluster? What does that look like for a client? Let's put it into the user interface in a generative way and see how the user interface handles that excessive data. So having that data-oriented approach to delivery has been really, really powerful for us as a company that's trying to deliver a small company delivering a big product, you know. So I'll get rid of the entirely generated operator and switch back to the actual operator that is running against a live cluster that I can do stuff in. And the last thing I'd like to show you about Clojure is about the power of it being hosted between the JVM and the browser. So let's say I wanted to just look what it looks like to see if I change an element of a page. I want to switch from the back end, working on the back end, to working on the front end. Well, I've got a REPL here that's working in the JVM, and it's doing Java-based Clojure stuff. And I can change that into a REPL that does ClojureScript browser-based stuff and actually connects to this browser for live development against that product that we're trying to push out. So I've started something called Figwheel, which is going to give me a ClojureScript REPL, which is slightly different from the Clojure REPL, but it's the same language, and it's going to connect now to my browser over here. In fact, it may have done that already. I might need to refresh the screen. There you go, it's connected. So I can find this page. I happen to know that this is in broker.cljs, and it's in something called the summary. It's actually this here. So I could let me just take something out. Let's see what happens if I take an element of that page out. It is a little bit slow. There you go. I've just taken something out. I can change the title of something. Topic, I might change that to Melbourne, just because. So this is a really effective way of working and delivering running systems when you've got complete control over a generative front end, systems that run on the JVM and in the browser with one language that is fundamentally just data and functions. This is a function, this is some data. It's a really, really powerful way of working. And as Brian Gertz says, it's a mature language that runs on the JVM that has it's a complete diversion from Java. It's not trying to be a better Java. It's just a better programming language that is on the same host. So here's some takeaways for you. If you want to try OPERATR, there's some, you get a free 30-day license on our site really quickly. We've got something on our GitHub that is a completely local Docker Compose environment for playing with OPERATR, or even actually just spinning up a 3-node Kafka cluster. If you're interested in any of the stuff I've talked about today, you can use that and Docker Compose to get a Kafka cluster running on your machine and just have a play, do some programming of your own. And finally, we've been threatening for a while, at least 6 months now, to open source a library called Shortcut, which is going to be a thin skeleton of Clojure on the back end, Clojurescript in the front end, semantic UI at the top with a little navigation. And so if you're interested in really playing with the tooling that we've got, you can, you'll be able to clone that shortly. I say shortly, it turns out that launching a new product company in the middle of a pandemic is quite a time-consuming thing to do. But keep an eye on that repository, because we will push some code there shortly, and you'll be able to play with some of the stuff that I've showed you today if it's interesting to you. And so finally, I'd just like to say thank you very much to the Meetup as a whole, and to Hamit, Tim, and Andrew for inviting me to talk. And yeah, congrats again on hitting 3,000 members. That's really super exciting. It's a really great thing to have achieved. Thanks, everyone.
Fantastic. Thank you very much, Derek. That was a great presentation.
Tim, we had some questions on the chat. If you.
Yep. Do you have a minute to help us with some questions, Derek?
Of course. Yeah. Very, very happy to.
So the first one, someone asked, how were you running the Kafka clusters for the setup? Sort of questioning whether you were running them in containers or they were sort of bare metal machines.
Yeah, so the demonstration I was just giving today with OPERATR running against a Kafka cluster, though that Kafka cluster is actually, I'm not screen sharing anymore, but it's running on my machine. It's a 3-node Kafka cluster running with Docker Compose. And it's just something that we use for test purposes. So we just, the Docker Compose is all online in that, it's called local in our GitHub repo. So anyone with Docker can start a 3-node Kafka cluster pretty quickly. The instructions are there to get it going as well. It's really useful for being able to work in a really localized sense on a live running Kafka cluster. We also, we use Amazon MSK for a lot of our integration environment testing. So I think at the moment we've got a couple of MSK clusters running. It's just push button stuff these days. You can go into the Amazon console and spin a cluster up in no time at all. It's really, really cool actually.
Yep. Great. The next question was, how does OPERATR compare to things like the Confluent Control Center?
Yeah, it's a good question. So Confluent Control Center, and if people don't know who Confluent are, they're a phenomenal company that work in this space with Apache Kafka. They're the original engineers who built Kafka, and they built a fantastic company out of it. So I'd say that Confluent Control Center is a small part of a very big idea coming out of Confluent that has KSQL and all sorts of other stuff involved in it as well. And control centers sort of, well, to be quite honest, I've never used it myself because I've never worked with a client that's used Confluent platform. I've only ever worked with clients that use open source Apache Kafka. I think there's probably some overlap, probably 50–60% of the stuff you can do in one, you can do in the other. The Confluent platform requires an enterprise relationship and enterprise sales managers and stuff like that, whereas Operator's 16 cents an hour on the AWS marketplace. It's just one Docker container. So that's one big difference. I think the bigger difference is the idea. So my company, what we're intending to build is the best toolkit for engineers for Kafka that can be built. Confluent have much, much bigger ideas than that in terms of showing people how to build streaming compute applications in the enterprise, I think. So they'll probably go in quite different directions as well from this point on.
Sure. Thanks for that. Another question, and I think you might have touched on this already, but maybe we could get a quick one-line summary. Why Clojure, particularly over other JVM functional languages like Scala?
So it really is, well, to be quite honest, it was an accident. So 8 years ago, I happened to take a job that happened to have some Clojure in it. I'd heard about Clojure in the past. I was quite excited about it. And it was a really happy accident and an easy one to have as well, because I was really familiar with the JVM as the environment that I've worked in pretty much my whole career. And it turned out that it just made a lot of sense to me as I started building systems with Clojure that weren't necessarily distributed systems to start off with. But it's really the power of simplicity. And I think, you know, Groovy or a Scala or a Kotlin, they come with a lot more than Clojure in terms of really, I can't really speak about Kotlin so much, but they are a diversion from Java in some sense, maybe some syntactic sugar or just a slightly nicer or better or quicker experience for achieving things in a sort of Java-y mindset would be my guess. Clojure is completely different. It is just data and functions. And I think that pairs really well with distributed systems, because distributed systems don't care about your object model, basically, is the easiest way I can say it. So we, in Operator, we pull in data from Kafka, we change it straight into, from object graphs, straight into data sets, and we spin it right out into the cluster, and we can, Clojure comes not only with phenomenal data structures that are very simple, it comes with a core library of functions that do really useful stuff on that data. So calculating the frequencies of things or joining things together and filtering stuff out gives us real fine-grained control of our data as it flies through our system. And we're never, you know, really in Operator's world, building object models would be a real distraction. And you can't really do that in Clojure. So it's, it's good not to be distracted, I guess.
Cool. I'm going to inject my own little question in here, which is a little extension on that. In terms of performance, how have you gone with Operator seeing it scale on clusters? Have you seen it scale up to, you know, 6-node clusters, 10-node clusters with, 100,000 messages a second, or what kind of performance does Operator sort of scale up and handle sitting on top of larger?
Yeah, so it's a great question. And actually some of our customers, I can see some of their names on the call. So there's some people with some experience in this space, but
you don't have to name them, but broadly from a performance perspective.
I'll make sure they're muted. Yes, we've seen it scale to a fairly reasonable degree. So we've got customers all around the world now that are using Operator. I think in the last week there's been 15 countries or so that have been actively using the product. And a large cluster for us would be about 12 nodes. That'd be a pretty reasonable amount of work that Operator's got to do to get that observed and give you control over it. But what we find with the people that are using Operator is, 3 to 6 nodes is a pretty standard setup for our customers. And even on a 6-node Kafka cluster, you can easily be doing 10, 20,000 events a second if they're batched in particular ways, or it's so. I think early on, I'd say at the end of last year, we had a couple of very large clusters, to be quite honest, that might have been pushing it a little bit too far. but our product's really matured in the last sort of 4 to 6 months. This year, we're not so much concerned about monitoring individual clusters. We're more interested in monitoring multiple clusters and that highly available story that Operator has as well. So that's the stuff, the engineering that we're really focusing on right now.
We've just got, I think, 2 more questions. And we'll give you a break. What does Operator use for stream analytics? Does it use Flink or something else?
No, so we actually perform, so Operator takes metadata snapshots of your cluster periodically, and then we produce all of our own metrics out of Clojure. So we do all of the computation ourselves to produce those metrics, those graphs of 1 minute and 5 minutes, and we do that computation within Kafka streams. So there's really, Operator has a number of dependencies that it pulls in from Maven, but no other framework other than Kafka. There's no other database, there's nothing. There's literally just data flying backwards and forwards between your Kafka cluster and the Operator Docker container. So and then from the Docker container to the UI.
So for stream processing, it's really just using the Kafka Streams API.
That's right. Yeah, it's using the Kafka Streams API. Absolutely. It's internal to Operator. There's a couple of streaming compute things, and there's a couple of RocksDBK tables, if anyone's familiar with Kafka Stream stuff. And it really is built entirely from Kafka. So it has those same semantics as Kafka itself.
Cool. And one last one, and this is a really great question from someone in the audience. It says, does Operator integrate with Schema Registry? Because we noticed that there's some functionality you showed us where you can actually go and look at data and you actually do the schema comparison. I think you're able to show us, which looks really
Yeah, it's a phenomenal question. So yes, Operator fully integrates with the Schema Registry. It can, if you're inspecting a topic and you're searching for data on a particular topic with a key and the key is encoded with a schema in the registry, Operator handles all of that for you. And basically just shows you your data in a sort of a JSON-y representation. So it boils it down to generic Avro data representation for you. So you can, in our Schema Registry Explorer, you can diff and edit and update and delete schema subjects, but your data that is sort of governed by those schemas, you get full access to that in our inspection and also production. So you can produce messages from Operator to topics that conform to schemas within your Schema Registry. Yeah, it's fully bolted on basically.
Oh, great. That's fantastic. Well, thank you again for coming in and sharing with us. I think Harmeet's recording this, so we'll upload that to the YouTube channel, I think, after the presentation, and we should be able to get a link on the Meetup page. So if anyone wants to come back and